In this video, we are going to find the value of tangent squared of 20 degrees plus tangent squared of 40 degrees plus tangent squared of 80 degrees. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. One thing that these three angles have in common is that if these angles are tripled, then it will become a special angle. Say, for 20 degrees, if we tripled it, we have tangent 60 degrees, and we have square root of 3. For 40 degrees, if I triple it, then it's 120 degrees, and tangent of this angle is minus root 3. Whereas for 80 degrees, triple is 240 degrees, tangent that is root 3 again. And from this, we can tell that all of these tangents squared will be equal to 3. So I can say that for these angles 20 degrees, 40 degrees, and 80 degrees, there are solutions to the equation tangent squared of 3 theta equals 3. So now we can rewrite this equation in terms of theta, just in terms of tangent theta, and see what we'll get. So we need to use the triple angle formula, and that's derived from the compound angle formula. So since tangent 3 theta is equal to tangent of 2 theta plus theta, and then it's the compound angle formula, tan 2 theta plus tan theta divided by 1 minus tan 2 theta tan theta. So for tangent 2 theta, we have 2 tan theta minus 1 tan over 1 minus tan squared plus tan, all divided by 1 minus 2 tan theta over 1 minus tan squared theta multiplied by tan theta. And then simplifying the top, combining the two terms, we have 3 tan minus tan cubed over 1 minus tan squared, while for the bottom, we have 1 minus tan squared minus 2 tan squared over 1 minus tan squared again. So finally, we have 3 tan minus tan cubed all divided by 1 minus 3 tan square theta. And now this whole fraction squared has to be equal to 3. So therefore 3 tan minus tan cubed all squared is equal to 3 times 1 minus 3 tan squared all squared. And then we expand both sides. For the left, we have tan to the power 6 minus 6 times tan to the power 4 plus 9 tan squared equals 3 times 9 tan to the power 4 minus 6 tan squared plus 1. And so altogether we have 10 to the power 6 minus 33 tan to the power 4 plus 27 tan squared minus 3 equals 0. And for this equation of tangent theta in degree 6, we have theta equals 20, 40, and 80 degrees to be some of the solutions. We know that the degree is 6, so there ought to be 6 solutions. But because all the terms we have over here have even degree, degree 6, 4, 2, and a constant term has degree 0, so we can say that for these three given solutions, in fact, minus of these numbers should also be solutions. So then we have all the solutions over here, which are plus or minus 20 degrees, plus or minus 40 degrees, and plus or minus 80 degrees. Now, how does this help us to find the value of the sum of squares of tangent of these angles? Now, in fact, we can rephrase this information as tangent, I should say plus or minus tangent 20 degrees, plus or minus tangent 40 degrees, and plus or minus tangent 80 degrees are roots to the equation, say, z to the power 6 minus 33 z to the power 4 plus 27 z squared minus 3 equals 0. Now then we have purely algebra inside this equation. So we don't need to consider trigonometric ratios together with the polynomial equation. Now, in fact, our required expression is actually close to the sum of squares of all the roots to this equation of degree 6. In fact, if I label these roots as, say, z1, z2, z3, z4, z5, and z6, for the first two, it refers to plus or minus 10, 20 degrees, and so on. We know that our required expression, required value, is equal to half of the sum of squares. Because for each of these roots, the squared will become, say, tan squared 20 degrees, which occurs 2 times at z1 and z2. And then we have tan squared 40 degrees for z3 and z4, and so forth. So we've now rewritten our required value as half of the sum of squares of a polynomial equation of degree 6. So we can bring in the Vieta's formula. In fact, sum of squares can be found by half of sum of roots all squared minus 2 times the sum. I have to write it as the sum of mutual products, which can be obtained from the third coefficient, starting from the one with the highest degree. And by the Vieta's formula, we know that this is equal to half of sum of roots is actually the coefficient of z to the power 5 over the coefficient of the leading term, z to the power 6. And so sum of roots is actually 0, which is natural because we know that the roots follow a pattern of plus or minus, and they form 3 pairs of plus or minus some tangent of some angles. So the sum is clearly 0. Whereas for the mutual products, where we choose 2 of the roots among the 6 each time, and then we multiply them, and then we add up all the products we get, that is actually equal to minus 33 over 1. The 1 is the coefficient of z to the power 6. So this sum is easy to calculate. Minus 2 times minus 33 is 66. That divided by 2 is 33. And this is the final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.